Okay, last video for this particular lesson where we're analyzing functions with successive differences, aka looking at things through different pieces of information and being able to tell what kind of function it is. All right, so we are going to do this now using tables or ordered pairs or any other way. They're going to give you information where it's not a graph, where you don't have access to a graph. So how can we look at these numbers and the relationships between the numbers and determine, oh, okay, this is this kind of thing. And this is without being given, obviously, an equation, because when you have an equation, it's really clear what kind of function it is. But this is like getting your outputs and saying, oh, all right, this must be this. So let's take a look. So the patterns we're looking for, okay, are there. There's a sort of a process you're going to want to follow with these. So the first thing you're going to want to do is you're going to want to do the good old slope thing, where you're going to see if there's a linear relationship, meaning that the rate of change from each y compared to each x is the same. And in all of these tables, they're usually going up by 1. So that means that y should increase or decrease the same amount between successive values. All right. So if this is the case, meaning that the difference is equal, you have a linear function. All right. So that's what that's saying here. Now, if that doesn't happen, the next thing you're going to do is you're going to look at the differences between those differences. So you'll see what I mean when I say that, when I do this later. All right. So if those happen to be equal, then you have a quadratic function. And then the last thing is if that's not equal, if you're still looking at something that's, a little weird, then what we're going to do is we're going to look at our original y values, and we're going to see if there's actually a ratio, like a multiplicative or, ratio between each y value that is consistent, right? See if there's a consistent ratio between them. And if we have that, then we'll have an exponential function. So let's take a look at some of these examples. So in this example right here, we know all these go up by 1 each time, right? So I don't need to write that out, and that's going to be the case in almost all of these. And then here you'll see, okay, it goes down by 4, goes down by 2, and then it stays the same, and then it goes up by 2. All right, so this is obviously not a linear, right? So if we got linear, quadratic, and exponential, it's not a linear because it doesn't go up the same. And so now what you do is you look at these successive differences, okay? So this successive difference, this went up 2, right? This went up 2, and guess what? That went up 2 as well, all right? So if that's the case and that's what's going on, and then we said that that would be a quadratic. So this one is a quadratic equation. The other way to tell a quadratic too, a lot of times, is if you do see a turn in the data. In other words, you see it where it's going and it's like going down and then it goes up, and if you see something like that and where it's turning like that, it's going to be a quadratic, because that's the natural shape of the parabola, right? It's going up and then it's going down, or it's going down and then it's going up, right? So that's how you can tell if it's going to be quadratic, is that bell curve shape. All right, this one right here, what do we got going on? Well, these are each going up 1, right? So we got +1 on all those, and then it looks like this goes up 5, this goes up 5, this goes up 5, and this one's an easy one. Constant rate of change. Y always goes up 5 for every one it goes over. So this would be linear, and then you have a slope of 5, right? So we know that much about it. Great. We also know that the y-intercept is -8, so we could actually write this if we wanted to and say y equals 5x minus 8. Okay, last one. So you're going up your 1 each time, all right? So all of those, you're going up 1. And this one, you're going from 0.75 up to 3, all right? So that is, you are increasing in a total amount of 2.25. Then you're going from 3 to 12, which is 9, so this is definitely not linear. 12 to 48, which is 36. And then 48 to 192, which is 134 or 140. Yeah, it's 144, sorry. 144. Okay, so not linear. Now let's check our second set of differences. And hopefully you can see from doing this that, you know, this one's going to be 6.75. This is putting me at, oh, my brain is completely not working right now, 27. And then this one is, you know, it's not 27 or 6.75, right? It's 100 and something, 108. So not quadratic, all right? So you could say, oh, well, it must be exponential. But what we have to do to make sure it's exponential is we have to look at these original values, and we have to see if this ratio is the same as this ratio. See if that's the same as this ratio. So let's do that, all right? So let's check our first one. So let's say we're going to do the top one to the bottom one. So or the one to the right over the one to the left. So 3 over 0.75, how many times does 0.75 go into 3? Well, it goes in 4 times. All right, so your ratio for that is 4. And then if we look at the next one, all right, so we go 12 over 3. Well, that's 4. So this is looking pretty good so far. Let's check the rest of them. If we do 48 over 12, that gives me 4. And then let's pick green for this last one here. And then if you do 192 over 48, you are also going to get 4. So this one is exponential. All right, this is exponential. It goes up according to a ratio, a common ratio that it shares. And so this would be something that it would be something where you're going to have 4x, 4 to the x, right? Because that's your common ratio. And then we would just need to figure out what our a is, what our multiplier is here to get it. So that at 0 it's 3, because 4 to the 0 power is 1. So maybe it's 3 times 4 to the x. I don't know. If we put 1 in, 3 times 4 would be 12. If you put 2 in, 16. Yeah, so this would be y equals 3 times 4 to the x power. All right, so hopefully you're seeing that these aren't really that confusing, and you can determine this on your own. The Alex assignment for this is really pretty short and I think pretty straightforward, so you should do well. So good luck, guys.